Chapter 9, Section 1 in the 8th grade note-taking guide is entitled Samples and Surveys. So this is where we begin our study of statistics and probability by looking at proper sampling methods. If we don't understand how we gather information correctly, it's hard to talk then about accurately giving probabilities of things. It's like saying, I don't know how to count money, but I know I have $1,000 in my checking account. How are you sure? It's the same idea here. If we don't understand how we actually correctly take a survey, do things like that, we can't correctly give statistics and probabilities that relate to that population that I'm supposed to be talking about. So here, that's where we start looking at probability and statistics with samples and surveys. So what is the population? The population is the entire group of people being considered for a survey. For instance, if I'm surveying people in the 18 to 29 age demographic that watch TV, then the entire group being considered would be people ages 18 to 29. A sample is a part of the population being surveyed. So if I'm talking about that age group 18 to 29 and I pick 500 people in that group to survey, all right, that's my sample, those 500 people that I happen to pick. Now, how you pick those 500 people, that's where the next set of definitions come in. A random sample is a sample in which each member of the population has an equal chance of being selected. A sample in which each member of the population has an equal chance of being selected. So this is something that's very random. If I were to open a phone book and just start pointing at different names in the phone book, that would perhaps be random. If I put a bunch of people's names in a hat and drew out certain ones, that would be random. If I took a computer database and told it to just randomly pick 500 names, that would certainly be random. You can also do a systematic sample. That's a sample in which a member of the population has been selected at random and then others are selected by using a pattern. So, taking the idea of the computer database, let's say the computer happened to pick out the 5th name. And then I just said, okay, since it's picked the 5th name, I'm going to then pick every other 5th name. Well, as I keep doing that, that's me using a pattern because I'm picking out every 5th name. That's a systematic sample. A convenience sample is a sample of a population that has been selected because they were most available. So if I said, I'm going to pick the people that are age 18 to 29 that are in this room to survey, that's a convenience sample because they just happen to be around and I can ask them and they fit the demographic. A self-selected sample is a sample of a population that has been selected because the members volunteered to respond to the survey. So if I picked a bunch of people age 18 to 29 and I mailed them a copy of the survey and I only then took the ones that answered back, that's a self-selected sample. Again, from the top quickly, population is the entire group being considered for a survey. A sample is a part of the population being surveyed. A random sample is a sample in which each member of the population has an equal chance of being selected. A systematic sample is a sample in which a member of a population has been selected at random and then others are selected by using a pattern. A convenience sample is a sample of a population that has been selected because they were most available. And a self-selected sample is a sample of a population that has been selected because the members volunteered to respond to the survey. Alright, so with all those definitions in mind, let's go ahead and start taking a look at the examples here. In example number 1, it says the manager of a company wants to know how many employees have a laptop computer at home. And then what it says is we're supposed to identify each type of sampling method. So this is going to be one of those last 4 definitions is going to match up with the scenario they describe. We're supposed to say which definition is described. It says the manager randomly chooses 40 names from a list of all employees. Well, notice key word here, operative word, is they use the word random right in the question. If they're doing it randomly, it's got to be a random sample. Now, be careful, because they could be talking about a systematic sample. If they said they did it randomly for the first one, let's say it happened to pick the 6th name on the employee list, and then that guy went down the list and picked every 6th name, it looks like it's random because the first one was picked randomly, but it's actually systematic because they've picked then every 6th name. That's what systematic is. All right, randomly means every single name in the list has to be selected at random. As we take a look at 1B, it says the manager surveys the first 50 employees as they arrive at the office. Well, that's a convenience sample. The reason that's a convenience sample is because he's having to pick the people that are the first 50 people into the office that day. All right, he's not doing anything at all that's random about it. It's just a convenience sample because they're the ones that are most available to him. They're easy to reach. Now, I want to make sure I point out, just because it's one particular type of sample doesn't necessarily make it invalid. It could be invalid, but that doesn't mean it necessarily is. You have to look at the results, and one of the things statisticians often talk about is the proper sample size. If I go back to my example of people aged 18 to 29, if I was talking about TV, 500 people is not enough because there's a lot of people aged 18 to 29 in the world. You have to have a sample size that's reflective of the sample. If it's a lot of people and I went out and surveyed just 2 and said, these are my results, I haven't surveyed enough people. If I'm talking about 1 million people and I ask 2 people for their thoughts, let's say I'm asking them to pick Democrat or Republican for president, and they both tell me Democrat. Does that mean 100% of the population is going to vote Democrat? No, of course not. You have to pick a sample size that's the correct size to eliminate what they properly call type 1 and type 2 errors, which are errors based on the sample size and errors based on the actual process of taking the survey, of taking the sample. All right, so let's go ahead and continue on here and look at example number 2. In example number 2, it says we're supposed to determine which sampling method will better represent the entire population, and then we're supposed to justify our answer. So the sampling method for A says Keith surveys only the students he knows personally. B says Amanda surveys every 20th student on the school's enrollment list. Now that list they gave us a minute ago is really in order from best to, I guess I'll use the word worst for lack of a better term, best to worst sampling method. So the random sample is the best, the systematic would be the next one, and on down as we get to the bottom, the convenience sample is probably the least effective one. So if we take a look at what we have, since Keith is surveying only the students he knows personally, that's really a convenience sample. Amanda's is a systematic sample. Remember, that starts off as random, but then since she's then saying, okay, I pick somebody, now I'm going to pick every 20th student on the list, it's really a systematic sample. Well, because it's systematic, that's going to mean it's better. Now the question is why? The problem with a convenience sample is a convenience sample usually relies on then, because it's convenient, people you know. For instance, if I said to you, take a convenience sample of people's favorite type of music, you're probably most likely to go and ask a bunch of your friends because that's what would make it convenient, is it's people you always talk to. Well, chances are they're your friends because you have something in common, and that thing might be what type of music you like. So with that said, chances are you're going to get one type of answer most often because there's not much diversity there. There's not a lot of diversification in the answers because, again, you all have something in common. So chances are you're going to skew your data towards one option or the other when you take a convenience sample. Since Keith is only surveying people he knows personally, that's really a clear-cut idea of a convenience sample. Whereas Amanda's picking every 20th student, she may not know that person. She might, but she might not. She might not know every one of them. So here, at that point, that's a systematic sample, one step away from a random sample here, and that means it's going to be better. She's probably going to get some more diversity in her answers and probably closest to if we actually surveyed every single person, what type of results we would actually get. All right, now as we take a look at example 3, it says about 39% of all U.S. households have houseplants. Lee surveys a random sample of households from 2 towns in the state. Compare the samples with the national percentage. All right, so if we take a look at what happened here, Lee surveyed town A, and he shows that there are 84 households with plants and 116 without plants. So that means there's 84 with plants of a total 200 people or 200 households. 200 total because of course we're adding these up to come up with the total of 200. So 84 out of 200 have the plants, or in other words, 42%, 0.42 is a decimal. As he then looks at town B, all right, we have 112 with plants of, once again, 200 total. When we add these two up, we get 200. So we end up with 112 over 200, or 0.56, or 56%. So now let's compare our choices here. Town A at 42% is pretty close, because remember they said up here that about 39% of households have houseplants. Whereas when we look at Town B's average is much higher. Town B's average is at 56%, because when we did that division there, the 112 divided by 200, we yielded 56%. That's much higher. All right. Why might this be so? Well, let's think about options. Let's say we were in Alaska. Might I be more likely to have a houseplant there? Yes, it's possible. It's considered a cold climate. The growing season outside is very short. Would it be more likely somebody might have a plant inside? Yes, perhaps. Compensate for the fact there's nothing outside. Whereas if I'm in southern Florida, what's my chances of having a houseplant there? Might be a little bit lower. It's nice pretty much all the year there. Right? If it's nice all year, I don't have to bring a plant inside. I can let it grow outside all year. Things like that are things that determine the survey and the survey's results. That's the type of thing you're looking at here when we're looking at these types of data. That's why these things are required to have a large enough population set to take those skewers out, things that skew the data one way or the other, and come up with a true average of things. All right, so let's go ahead and take a look at the last page here. We'll start with number 1. It says you want to know how often students in high school take tests. Identify each type of sampling method. You randomly choose 40 names from a list of all students, and then every fifth name after that. We've talked about this several times in today's definitions here. That's a systematic sample. All right, it starts off, it looks randomly. It looks random because we're choosing 40 names from a list. But then it goes on to say we're choosing every fifth name after that. We've talked about that over and over again. It started off random, but then all of a sudden we're picking every fifth name. That's systematic. All right, if it starts off random, but then they go with that pattern that they've identified, that's exactly what systematic is. Again, your choices there are those 4 we saw in the definitions, those last 4, and you'll have questions like that in the homework tonight. As we go ahead and take a look at number 2, we're supposed to determine which sampling method will better represent the entire population, and then I'm supposed to justify my answer here. So in the A part there, it says Ferdinand surveys every other swimmer on the team. 72% want practice early. And then the second one, Anna Maria questions the swimmers who are in her biology class. 50% want practice early. Well, if we identify what these are, this is a convenience sample here for Anna Marie. That's very clear because she's only picking people that are in her biology class for the answer. All right, so that's definitely a convenience sample. Whereas Ferdinand is surveying every other swimmer on the team, that's a systematic sample. All right, because we see that every other thing, that's the personification of a systematic example. Well, again, as I said, when we're looking at that list of definitions there, the higher up you are on the list, the better your survey is. So as we look at that list, random was first, systematic was second, and then convenience is lower than that. So the systematic survey of Ferdinand is going to be better there. Why? He's taking out any bias. If we're talking about the biology class with Anna Marie, that class could be people that pick that hour because they're in there because they want to be in there with Anna Marie, or they want to be in there with their little group or clique of friends. All right, if we take that out, take that option out, which is what Ferdinand's doing by picking every other swimmer on the team, he may or may not like those people, then all of that possibility of necessarily the friendship for every single thing is gone. That's a systematic sample. All right, as we look at the final example here, it says about 22% of all U.S. households have pet fish. Brylan surveys a random sample of households from 2 towns in his state. Compare the samples with the national percent. All right, kind of a nice question here because the totals add up to 100, which makes it really easy to find the percent. So if we talk about town A here, there's 25 people that have pet fish. Of how many total? Well, it's 25 and 75, so that's 100. So it's 25 out of 100, or a fourth, or 25% that have fish. As we take a look at town B, it's 55 that have them out of 100 total. Of course, that's just going to divide out to make 55%. Now remember, they said back up here in the prompt that 22% have fish. So they're asking us to draw comparisons to that 22%. So obviously here, as we take a look at town A was pretty close. They came in with 25% matching. Indeed, that's a very close number, 22%. So yes, town A, very close to the national percent. Town B, way far off here. 55%, they have many more greater percent than the average national U.S. percentage.